Internet. Following on the other example that I did for Linux, if you remember, I did examples here where I showed or demonstrated how to organize the code into a pure C++, which is what we have here. This one, a pure C++, versus the other one is the extended C++, which contains the added syntax in C for CUDA to be able to express the parallelization. So it added the syntax here. So in my other video, I demonstrated that why such code organization is important and what are the benefits of doing that. You should definitely organize your code in this way. And I did that in a Linux machine, which I used the GCC compiler in the command line, the NVCC, and the GC and the G++, which is always is done in Ubuntu operating system. Like it is actually Ubuntu 18.04, which is just a nano. Okay, so now in my screen here, we are in a Windows machine, and the plan of action here is we are going to redo this the principle that I have discussed in how to organize code, and we're going to do it in a Visual Studio IDE. So I have just installed the CUDA toolkit here in my Windows 10, and it made its way in this past program files NVIDIA GPU toolkit. Okay, so it made its way here, and if we go back to the Linux machine here and we go examine this helper.h, and we can see that we had a dependency with the CUDA runtime header file, which is just actually uh, located here. Use R local CUDA. Okay, so this header file is located here, and so after installing the CUDA toolkit in a Windows machine, we should be able to also locate the same header file here. And let's try to do that. And I guess it should be, okay, let's just do it from here. And indeed, we are able to see the same CUDA header file. Okay, so there are lessons to be learned if we make it work first in Ubuntu or in a Linux machine, and then later on tackle the Windows. As in my experience, the Linux-based build system is clearer and more transparent. Okay, so let us continue. So now the plan here is let's going to create an app.cpp project that will do a matrix transpose and segregating the other parts of the the stuff that uses the extended C++, instead of here, which is in a which is in an it is segregating it in an object file. Okay, here in the Windows machine here, let's instead create a static library. Okay, so I'm going to launch my Visual Studio IDE 2019 now, and I'm going to create a new project. And because we installed the CUDA toolkit, we begin to see that um, there's actually a CUDA 12.1 runtime uh, project type here. And this is going to select this by default. Okay, since if I'm going to select this, and it's going to pre-populate all of the include paths and the linker paths. Okay, so I'm going to select this, and I'm going to next, and I'm going to name this helper. Okay, helper there, helper, and I'm going to create. So by default, it's gonna generate a executable, and it has an entry point main. So so if I'm going to build this, it's going to build an executable for me. But we can actually first let us try to get the body of the helper. Okay, I'm gonna get the helper.cu, and I'm gonna copy this stuff here, and I'm gonna replace everything in this code. I'm gonna delete this. In fact, I don't need all of this because we're going to create a static library. Okay, and I'm gonna paste this guy here. Okay, and well, this is just an unsigned int. It is just explode this to its native type. Unsigned int. There. And then we're going to change instead of creating an XC, we're going to go to the properties, and okay, here the configuration type, instead of resulting to a standalone executable, we're going to change this to a static library, lib, okay, and apply there. So because this is a Coda templated Visual Studio project, if we check the properties, we can also see other stuff that are preset for us already here. And we're not going to tinker all of this. Okay. Anyway, let's build now. And indeed, we have successfully built the static library that live here. All right. So now that it's there, I'm going to create a new project here. So add solution, new project, and it's going to be a standard C++ code. So it has nothing to do with Coda, but just empty C++ code here. Okay, so I'm gonna next, and I'm gonna name it up. Okay, so create, and let's gonna make this app as the default project, the startup, and let's gonna add a source file, main.cpp or app.cpp there. So let's go back to the Linux example, and we have an app.cpp here, and I'm gonna copy the contents of this app.cpp and paste it over here. And well, instead of including a helper.h, to make our life easier, let's just paste this directly into the code. It's basically the same story as adding a header file. Okay, and delete this. And now we are confronted with some linker um, uh, changes in our configuration here. Okay, because here the dim3 data structure is not a known type, because this is just an ordinary C++ project. It is not the templated project that unlike this one, the helper, which is already has the linker and the header set for it, and is but this one is just an ordinary C++. How can we therefore resolve this? For example, if we try to build this and we see we could not find the runtime that edge, because I've shown here that the runtime, the CUDA runtime is here. So let's go to the project properties, and in the add include directories, okay, here, and let's just add that path. That path is in drive C, program files, NVIDIA, computing toolkit, CUDA, and include. Select folder. Then I'm trying your call with drop. Okay, so I'm gonna click apply and okay, and let's build again, and surely we are now able to properly include the CUDA runtime.h because of the we specify the include path. But then we're confronted with the linking of the library. So, for example, the do transpose is here in this separate project here in the helper, and at the same time the if we go back here in the makefile, we can see that it's also linking to CUDA libcuda rt. And if we check here in the Windows lib, and we can see this CUDA rt lib. So we're going to specify also additional paths here in the project and go to the linker, input, general, and linker, additional linker directories. So we're gonna add paths to program files, NVIDIA, where's that? Here, computing toolkit, and B21 lib. We can see that the CUDA RT lib is in the lib x64. So here, select folder, and then after doing that, the, in the in the input section, general input, yep, in the input section, additional dependencies, we're gonna add the CUDA RT that lib, apply, then build again. And at last, the only unresolved function here is the one from our static library. And we can again do the same. Go to properties. We specify the path to the library, which is in the input here. And I think it's gonna go to drive D. It's in SRC, Visual Studio, and it should be helper. There should be a helper here. Helper, or maybe it's in C. Source user one. here helper and x64 debug. Okay, so the helper library is compiled here. Okay, and after that we're gonna add the specific helper lib here. Okay, helper dot lib. Um, let me check if indeed it's helper.lib. I'm gonna say equals helper. Yep, it's helper.lib. Okay, and apply. Okay, so build successful. Okay, we are now able to build an app exe that is linking to a coda, a static library. So we have achieved our goal of having a pure C++ code here. In the same manner that I demonstrated in the Linux tutorial a while ago. And let's try to debug this. Let's put a breakpoint here, pressing F5. Okay, there. Let's go to the and then let me okay, and then press F5. As you can see, we are able to transpose the array correctly, and hence proving that the coda operation was successful. And let us try to debug. Well, we don't have the source code of the static library because we are linking it in this helper.lib, right? So this is all we can do, and so this is how to do the same stuff that what we did in the Linux version, code organization. But the goal again is a big portion of your code base should be in pure C, C++, and you have to isolate the rest, those that has the coda extension into its own file. Here, we separated it into its own static library. We specified here, and it became the helper.lib. This is where the code stops here, and that leaves our code a pure C, C++. So that's it, guys. Thank you.